Hi everyone, Andrea Joss here, your prof for the protein section of Kin 4020. This is the last class that I'll be giving for you in this class. And this one is going to be a little bit longer than some of the other ones because I'm really excited to talk to you about sports and exercise nutrition and in particular protein. So remember, the last class was short, so this is kind of I'm taking a bit of time from that one and adding it to this one. I hope you don't mind, but I really thought that you, as kinesiology students, would really enjoy learning about protein in the context of exercise and sport, because there's a lot of information out there. So I'm going to take some time to go through this with you. If you find it too much, like too long of a class, just watch part of it, stop it, and then you can resume and watch the rest of it at another time. Okay, so I'll start with this discussion regarding how much protein do we really need by introducing this idea of this position statement that was written by the International Society of Sport Nutrition. So they came out with a recent position statement, and I have the link to it here, and actually on the next slide I talk a little bit about the features from this position statement. But just before we move on, to let you know what a position statement actually is. So there are many experts in the protein and exercise field that came together as members of the International Society of Sport Nutrition. They looked at all the available evidence and they put out this review paper with their endorsement of the latest research regarding protein and exercise. So this position statement details all of the latest research in this regard. There was also a recent LinkedIn post that was put forward by Dr. Stuart Phillips, and if any of you follow this protein area, protein and exercise, you've probably heard his name before. He's a very prominent protein researcher, Canada Research Chair at McMaster University. He's actually my PhD advisor. But anyway, he put out this really great perspective piece regarding protein. And he says, most of the protein that you consume is used for building other proteins. That's part of the reason why we have, we talk about protein consumption quite a lot, because there's a lot of our body that is made up of protein. We then can use amino acids and protein for energy, and then we also use to synthesize other proteins in our body, but most of it is used for building protein. Another point he brings up is that we can actually digest a lot of protein. So our bodies can digest it in the stomach, as I talked about, and even absorb it in the intestine. We can break down a lot of protein that we consume, but how we use the protein, there's really only a finite level of the amount of protein that our body can use to synthesize new proteins at one particular time. So making that distinction is really important, and I'll talk a little bit more about that in subsequent slides. And he also goes on to talk about the protein RDA. So protein intake more than the RDA is important for exercise and for muscle health. So if you recall, I talked about what the RDA actually was. So for adults, it's 0.8 grams per kilo per day, and this is the recommended dietary allowance. It's the amount of protein that we should consume to avoid issues. Okay, it doesn't necessarily mean it's the optimal amount of protein. So in order to have optimal protein function and maybe even to build proteins, we should be consuming a little bit more. So I will get into that a bit. Take a read through his LinkedIn post. It's a pretty easy read, and you can find it on this slide here. Okay, so here are the 7 points that are put forward in the International Society of Sport Nutrition position stand on protein and exercise. Number 1, individuals engaged in regular exercise training require more dietary protein than sedentary individuals. Number 2, protein intake of 1.4 to 2 grams per kilo per day for physically active individuals is not only safe, but it may improve the training adaptation to exercise. So recall, this is over double. Well, 1.6 would be double the RDA, but this is quite over the amount of the RDA, okay? One part of a balanced, nutrient-dense diet, protein intake at this level is not detrimental to kidney function or bone metabolism. This is a whole other area of research, but there's a lot of papers that have come out about bone and about kidneys and looking at the effect of protein on those. And for healthy individuals, there seems to be no adverse effects. While it is possible for physically active individuals to obtain their daily protein requirements through a varied, regular diet, supplemental protein in various forms are practical ways of ensuring adequate and quality protein intake in athletes. So essentially it's saying if you are going to take a protein supplement to improve your protein intake, that is okay. And this becomes potentially important if one is a vegan or a vegetarian and they're consuming plant-based proteins. Different types and quality of protein can affect amino acid bioavailability following protein supplementation. The superiority of one protein over another in terms of optimizing recovery and training adaptations remains to be convincingly demonstrated. We will get into this one in further parts of this lecture. But essentially, if you consume over a certain level of protein, like 1.6 grams per kilo per day, it really doesn't matter at that point what protein sources you're consuming. So you could have plant proteins, animal proteins, as long as you're over a certain amount, you can get your protein from a variety of different sources. So appropriately timed protein intake is an important component of overall exercise training program, essential for proper recovery, immune function, and the growth and maintenance of lean body mass. So we'll also talk about this issue of timing because there's been some more recent research that has come out challenging this notion of the anabolic window, so that timing is super important. But the devil's in the details, so I'll talk about that when we get to that part of the slide, or the presentation rather. And under certain circumstances, specific amino acid supplements, such as branched chains, may improve exercise performance and recovery from exercise. So again, if you're consuming at a higher level, like you're consuming a higher amount of protein, it's not as important to focus on the type of protein as it is the total amount. So BCAAs become less important, if you will. So in the position stand, they also talk about endurance versus strength and power exercise, and they show here that for both types of exercises, we do require increased amounts of protein. So in summary, it's the position of the ISSN and all the other professors and educators and researchers that went into writing this position statement that exercising individuals ingest a range of protein from 1.4 to 2. Individuals engaging in endurance exercise should ingest levels at the lower end, and individuals engaging in intermittent activity should ingest in the middle, and those engaging in strength and power should ingest at the upper end. Okay? So this meta-analysis by Morton et al., this is from Stu Phillips' lab as well, they published this in 2018, and it was a meta-analysis looking at resistance exercise and protein consumption in relation to strength and fat-free mass. So I'm showing you the results here for fat-free mass. You can see a graph here and a forest plot as well with all the different studies that they looked at. So they found in this meta-analysis that dietary protein supplementation augments changes in fat-free mass and strength during prolonged resistance exercise training. Dietary protein supplementation was more effective at increasing changes in fat-free mass, as we can see over here, in resistance-trained individuals, and less effective in older individuals. And then they also found that protein supplementation beyond about 1.6 grams per kilo per day provided no further benefit on gains in muscle mass or strength. So we can see this with respect to fat-free mass in this figure over here. They did some fancy statistics, and they were able to show that on this end, so below 1.6 grams per kilo per day, as you increase the amount of protein from around the RDA up to 1.6, you're seeing greater increases in fat-free mass. And then statistically, they were able to derive this break point at about 1.6, which shows that any additional increase of a relative amount of protein intake was not associated with the same linear increase in fat-free mass gains. So we actually see a flattening of the curve, which indicates that there's diminishing returns with greater increases in protein intake. So 1.6 grams per kilo per day seems to be that magic number according to all these studies that they looked at. And then these ones over here is just showing that we can get greater gains in fat-free mass with the consumption of protein. And in this meta-analysis, you looked at all the results of these studies, and you have this point estimate, which is a summary of all of the different estimates that you see here. We do see that it favors increased protein intake. So protein is helpful for improving fat-free mass. This is an infographic, actually, of the results that I just showed you. So knowledge translation is a really big thing in our field. So making sure that people get the right information from the research. So preparing a figure like this is a infographic. You may have seen several others of them. And actually in this slide deck that I have for this class, I put in a couple different infographics because it really, tells you the main points of the research study in a visual kind of way that is able to translate the information from the paper into a way that other people can understand it. So this is the same as what I just showed you, but in an infographic form. Okay, so the belief then is that athletes require very large quantities of protein for optimal athletic performance. And I'm going to say that, in the extreme setting, so you have bodybuilders, of course, that put on a tremendous amount of protein. I would say that these two individuals probably consume a ton of protein and way more protein than, an average exercising person. So the exception is certainly bodybuilders and strongman athletes with respect to the amount of protein they consume. But this is pretty much a belief, and I'll tell you why. Most athletes don't require that much more protein than general healthy people. And this is part of the reason why, okay? So let's do the math here. We have an 80-kilogram male consuming around 4,000 calories per day. So this is an active runner, let's say, for example, okay? If they consume around 15% of their energy from protein, and again, remember, this is the lower end of the AMDR, which is from 10% to 35%. This equates to about 600 calories per day from protein. And if you do the math with 4 calories per gram, we end up with around 150 grams per day of protein. And if we figure out the relative contribution of protein to this person who's 80 kilograms, this equates to a protein intake of 1.9 grams per kilo per day. So this is above that 1.6 threshold that they found in the meta-analysis. So my point here is that if you are eating a lot of a balanced diet, okay, so here we are, 4,000 calories per day is a lot, even though protein is only around 15%. If you're eating a lot of a balanced diet, you generally don't need to worry about maximizing your protein intake, even if it's at the lower end of the AMDR, like I've shown here, because this does still translate based on a per kilogram basis to a really high protein intake. So at this point, the athletes then start to worry about other issues regarding how their body can best use this protein. So the timing of protein intake, the quality of protein they're consuming, and things like that. So I just wanted to make that point over here. And perhaps this is slightly different when you're talking about, strongmen or bodybuilders, which are just constantly eating protein. So with respect to protein requirements for exercise, is there a greater requirement? Yes, I've told you that. The position stand has told us this. Well, let's break this down a little bit more. With respect to aerobic exercise, okay, these athletes and individuals doing aerobic exercise do require more amino acids. And the primary reasons why is because they need them for fuel. So they do actually oxidize amino acids, particularly if they're near the end of their exercise bout, the end of a marathon or however long they're running for, and they would run out of fuel. Amino acids actually do become an important part of the fuel for these athletes. They can make up even more than 10% of the fuel at that stage. And also, when you're running a marathon or doing a lot of aerobic exercise, you do need to repair your muscles after. So for those reasons, aerobic athletes or endurance athletes do require more amino acids. With respect to strength, this is more clear in people's minds usually. Those that practice strength exercises or do resistance training, they do require more amino acids as well. And this is primarily to build and repair their muscles. They don't necessarily oxidize amino acids at the same rate, but they undergo more muscle damage potentially. So there's slightly different reasons why, but at the end of the day, both athletes do require more protein. So these are some additional questions that we're going to now explore for the rest of this lecture with respect to protein. So we're going to get into some of those nitty-gritty details. We'll talk about the amount of protein post-exercise that seems to be the most beneficial. We'll talk about optimal timing of protein ingestion, and we'll talk about the types of protein to ingest and some of the latest research out there, particularly around plant and animal-based protein sources. So before we get into these details, I just wanted to talk about this daily pattern and this notion of protein turnover in the body and how our body deals with protein. When you talk about the daily pattern, we're essentially talking about protein turnover and this relationship between MPS and MPB. So muscle protein synthesis is MPS and MPB is muscle protein breakdown. And our body is in a constant state of turnover. This can happen for all of the proteins in and around our body. I am going to channel this discussion more to skeletal protein, okay? So we're going to talk about skeletal muscle with relation to this discussion. So over the course of the day, we have a fluctuation in our muscle protein synthesis and a fluctuation in our muscle protein breakdown. Okay, and it's usually quite constant because we tend to eat meals at constant times, we get hungry, and our body is just really responding to the increases in amino acids and then the loss of amino acids. So we're talking here about the fed state gains versus the fasted losses and how our body deals with that. So when we consume a meal, this provides a stimulus for our body to increase muscle protein synthesis because the amino acids turn on the muscle protein machinery and this causes an increase in protein synthesis. So what happens is we have this increase in synthesis, then our body uses the amino acids and we end up having a reduction in protein synthesis such that we have some fasted state losses. And then we consume another meal and supply the body again with amino acids, and then we have this increase in synthesis, and then a decrease in synthesis. And we just keep having this cyclical response. Now, with respect to muscle protein breakdown, this also follows a similar response, as you can see here, but it's less variable with the increases in amino acids. It generally stays relatively the same. So when you consume a meal with amino acids, you have a slight reduction in protein breakdown. And then when there's no amino acids in the system to stimulate synthesis because you've used them, then you have a slight increase in breakdown, and then you change this. So over time, if you eat balanced meals with enough protein, you will maintain in this state of protein balance throughout the day. Now, what happens then if you actually add a further stimulus to the mix? So here we're adding in resistance exercise, and resistance exercise really sensitizes the muscle to increase protein synthesis and to use the amino acids that are provided to it. Exercise in and of itself is a stimulus for muscle protein synthesis, as we can see here from this figure. So if we undergo resistance exercise and then we also consume a meal of protein, we see that there's an additive effect here of these fed state gains. So both resistance exercise and increase in protein intake causes an increase in muscle protein synthesis. And then over time, this results in a reduction, and we have our fasted state losses again. And then we consume another meal, and we have greater increase in gains, and then our fasted state losses. But with resistance exercise, even if we're consuming the same amount of balanced meals, we have greater fed state gains and lesser fasted losses, so that over time, our muscle protein synthesis is greater than our muscle protein breakdown, and this actually causes an increase in the accretion of muscle protein and hypertrophy. So this is how resistance exercise and protein work together to create hypertrophy. You'll notice here muscle protein breakdown is the exact same as it was on the other slide. It's a necessary process to help with this remodeling of muscle, but it's not as affected by resistance training or amino acid consumption. It's really the muscle protein synthesis part of the figure that is affected by exercise and consumption of protein. So with that in mind, there's been many studies that have been done actually showing that over the course of 48 hours, we can see with this particular slide, when you exercise, you see an increase in muscle protein synthesis. And if you add amino acids to the mix, so if you take in some protein as well, you see an even greater increase in muscle protein synthesis. So that is what this figure is showing over here. This is from 2009. And the y-axis is just muscle protein synthesis in arbitrary units. And we have at rest, we have 3 hours post-exercise and amino acid consumption, 24 hours and 48 hours. And so the main points of this figure are that resistance exercise induces a sustained increase in muscle protein synthesis for up to 48 hours. So we see here that this bar is higher still than the rest bar 48 hours later. So if you do one exercise bout, your body is still feeling the results, the positive results of that exercise bout up to 48 hours later. So that's speaks to the power of actually doing some muscle activity and doing some resistance exercise to help with muscle mass. Now, what we see here is that if we also consume amino acids on top of the exercise, we actually see greater increases in muscle protein synthesis. So if you exercise in the fed state or allow your body to use amino acids after you've done exercise, you see even greater gains. So this is an additive effect of both exercise and amino acids. The white bars over here is exercise in the fasted state. So again, you can see after an exercise bout, you have an increase in muscle protein synthesis, even up to 48 hours later. And if you add in the amino acids, you see this increase is even greater. So feeding along with exercise, both of them together can help with improving muscle protein synthesis. Exercise has a bigger effect, and that's still the case. To answer this question of how much protein post-exercise, this has been a question that many people have asked over the years, and it's a really important one. This particular study kind of gives us a really good idea of how much is necessary. This was a study done in 2018 from one of my colleagues, also from Stu Phillips' lab, and this was done in young, healthy males. And they showed that muscle protein synthesis after one bout of resistance exercise in response to increased amounts of dietary protein. So they had participants come in, they exercised them, and they measured their muscle protein FSR, so that's fractional synthesis rate of muscle, after the consumption of varying doses of protein. So you can see the different doses here. So there's 0 protein, 5 grams, 10 grams, 20 grams, and 40 grams of protein in these participants. And what they found is that consumption of between 20 to 30 grams of protein is really the amount that one can use in the body to maximize the muscle synthetic response. So what they see here, if you're looking at this graph, the letters that are above the actual mean values over here, if they're different from one another, this indicates that there was a different response. So 0 grams of protein after exercise showed the least response with respect to muscle protein synthesis. 5 was better than 0. 10 was better than 0. 10 and 5 were not different from each other. 20 was better than 10 and 5 and 0, but 40 was no better than 20, okay? And in fact, when they consumed 40 grams of protein, they actually saw that there was a greater increase in leucine oxidation, or a greater increase in amino acid oxidation, or the use of amino acids by other tissues other than muscle. So this indicates that your body uses well at least about 20, maybe to 30 grams of protein at one time. But if you give your body more than that at one time, it may digest it well, like I said before, but it's not going to use the muscle protein, or it's not going to use the amino acids to build muscle protein. It'll channel it to other areas. So this is where we've come up with this idea that around 20 to 30 grams in a bolus of protein, a protein shake, or in a food that you consume is a good amount to have. And this could also translate to about 0.25 to 0.4 grams per kilo per meal. And if you consume around 4 to 5 meals per day, meals and snacks of about this, then you will get enough protein in the day to theoretically, as they say, maximally stimulate your protein synthetic response. Okay? And as I've written here, more protein does not equal more muscle protein synthesis. And we can see this here. Even if you consume 40 grams of protein, it doesn't translate into more FSR. Again, you just use it in other areas. What about timing of protein intake? So this is another thing. So we've established the amount of protein at one time that your body can use to improve muscle protein synthesis. But what about timing? So protein immediately post-exercise is likely the most beneficial. So this is to say that, you know, at this time, after you've exercised, your muscles are engorged with blood and you know, they are waiting for the amino acids to come to them so that they can improve the recovery process of the muscle and start the synthetic process. So immediately post-exercise is likely beneficial. Supplying amino acids, as I said, when the system is most ready, can't be a bad thing, okay? So this is during that anabolic window. Now this does not mean that, you know, after you lift and you're done your workout, you have to have your protein shake right beside you in the gym and you're ready to down it. That's not what I'm talking about here. So probably the anabolic window is within an hour, let's say, of finishing your exercise bout. You want to supply the body with amino acids, particularly again when the muscle or the blood flow is diverted towards the muscle, because this will allow the amino acids to get to the muscle quicker, and the muscle is already ready to take them in and use them. Amino acids and carbohydrate consumed together is also a potential strategy, or it's a strategy that's been assessed because of this notion of increasing insulin secretion, which helps with the uptake of amino acids into the muscle. So insulin may help in this regard, and so that's why consuming a recovery beverage that contains carbohydrate would also be beneficial here. And you know, some people talk about chocolate milk in this regard because it contains amino acids. It also contains some sugar in it, and so that would have an effect on the insulin, which would potentially help with uptake of amino acids at the muscle level. What about branched chain amino acids? And I put a question mark over here. So the latest research out there is that if you're supplementing with just branched chain amino acids, they say this is no better than, you know, an essential amino acid supplement or a general protein supplement, or even consuming protein foods if you're eating at the right amount. So if you're consuming 1.6 grams per kilo per day, you're consuming your, you know, 0.25 to 0.4 grams per kilo per bolus, then consuming additional branched chain amino acids on top of that, or just consuming BCAAs, it really doesn't add that much extra. So maybe it's a waste of money in some ways. We should focus on potentially eating whole food sources of protein, because they also provide you with other nutrients that may be beneficial for the process. ISSN has another position stand on nutrient timing. If you're interested in taking a look at this one, they discuss a lot of what we talked about in terms of providing protein during this anabolic window. And then recently there's been some other papers that have come out talking about whether timing actually matters in the context of looking at total daily protein. So this is a really interesting point, and I actually do agree with this in many ways. If you're consuming 4 to 5 meals a day, as I alluded to on the previous slide, of a protein intake of 0.25 to 0.4 grams per kilo per day, that level of protein at the various times in the day, if you focus on just doing that, you're likely going to be consuming protein during your anabolic window anyways, okay? So perhaps if that's your focus on making sure that your total daily amount of protein that you consume is adequate and it's spaced out properly, you really don't need to focus on consuming protein the second you're finished your exercise bout, because you'll likely be providing your body with protein throughout the day at a steady, adequate level in which you will be maximizing your synthetic response already. So some research has actually been done showing this, and they've kind of manipulated when people consume protein and how much the actual boluses of protein they consume are. And they've really shown that if you have a steady increase or a steady amount of protein throughout the day, split up into 4, let's say, meals of the same amount, that is sufficient in terms of the stimulus for protein synthesis, the same as, you know, really focusing on having protein post-exercise. So in that context, I can understand why focusing on timing post-exercise is not as important when if you take the approach of just, you know, maximizing your intake throughout the day, you will hit that anabolic window anyway. So take a look at some of these other articles also published in the Journal of the International Journal of Sport Nutrition. This is another interesting area of newer research with respect to timing of protein intake. And this is this notion of consuming protein intake before we go to bed at night. And I've highlighted some papers over here that kind of give this perspective. And this is their theoretical take on it over here. So we've seen these graphs before at the start of the lecture. So I put these in there because we're already kind of oriented to them. But you can see here that if we don't consume protein before we go to sleep, we have this fasted state loss. Okay, so if this is the protein synthesis, the MPS over here, we can see when we go to bed at night, essentially we're sleeping, let's say, for 8 hours or something like that, if we're lucky. We sleep for 8 hours and we don't consume food. So this is an 8-hour time window, if you will, where your body is where muscle protein breakdown overweighs muscle protein synthesis, and so we tend to lose a little bit of muscle mass when we're sleeping. And this is kind of what we're seeing here. And so they've had this idea, the researchers have had this idea that sleep, so at night, this becomes a protein feeding opportunity. So you want to try and minimize the amount of time that you're in this catabolic state. And when you're sleeping, when you're not consuming food, then this is the catabolic state. So what they talk about here is that right before bed, so 11 o'clock at night or so, right before you go to sleep, have this pre-sleep protein bolus. So casein protein is what they looked at. And theoretically, what should happen is that this should put you back up into an increased rate of muscle protein synthesis while you're sleeping, and so then you avoid this muscle protein breakdown stimulus at night. Okay, so that's the notion here. And you can see from these figures here that they actually ran a 3-month study looking at resistance training and, you know, around 30 grams of casein protein consumed before bed. And these are figures of the change in cross-sectional area of the quad. So the size of the quad here, this is the change, and then this is the pre-post. They actually saw that there was a significant increase in quad cross-sectional area in those that consumed protein before bed compared to those that did not, that were given a placebo. So perhaps there's some interest here or some utility here in actually consuming protein before bed. And in fact, some of the studies that I've done in my lab where we've given participants Greek yogurt with a resistance training program, they were supposed to have 3 boluses of Greek yogurt during the day, and one of them we actually instructed the participants to consume the Greek yogurt before bed, and it was based upon this particular study. And I'll actually show you a slide on that study a little bit later on in this talk. But so there may be some utility here of consuming protein before bed, particularly some slower digested protein like a casein protein, which allows for this increase or this sustained increase in muscle protein synthesis while we're sleeping, which would otherwise be dominated by a catabolic phase. So what about type of protein intake here? So there's a lot of research in this area, and so I'll start by showing you 2 particular figures over here. This one is a infographic, which I'll get to in a moment. But over here we see that providing a placebo versus 40 grams of mixed amino acids versus 40 grams of essential amino acids after resistance exercise actually has a different effect on protein balance. So we're looking at nitrogen balance or muscle protein synthesis and breakdown, and this is a measure of those entities over here. We have protein synthesis, breakdown, and the balance between the 2. And we see here that providing a mixed amino acids versus essential amino acids, both of them show a positive nitrogen balance. If you give nothing, then you can still be in a negative nitrogen balance. So this is to say that providing protein post-exercise, be it a mixed protein source or simply essential amino acids, this results in an increase in muscle protein synthesis or an increase in overall nitrogen balance. So protein post-exercise is a good thing. We actually see a bit of a greater increase if you give essential amino acids, and this is likely because of the use of branched chain amino acids in this regard. But also, our body can't make essential amino acids, and so providing them to the system may help with creating new protein more than just providing a mixed amino acid. Than just providing mixed amino acids. Okay, so that's the first thing we can look at. Protein is beneficial. Essentials are even more beneficial. Okay, this is an infographic that was put out by Asker Yukendrup, and he runs this My Sport Science. It's a excellent resource. I actually encourage all of you, if you're interested in this type of stuff, I encourage you to follow him on Twitter and to sign up for the blogs and the information that he puts out. And he puts out a lot of these different types of infographics. Okay, so this one in particular was a study by Tang et al. And they looked at whey, casein, and soy protein post-exercise. And here's our measure of fractional synthesis rate of muscle protein synthesis. Sorry, I think my kids are jumping around upstairs. That's why you can hear them. They're doing some jumping in their class, so I apologize if that's a bit loud. In any case, so if you look at the different types of protein, whey, casein, and soy post-exercise, we can see here that whey actually stimulates the fractional synthesis rate of muscle protein synthesis to a greater extent than casein protein does and than soy protein does. And actually soy was not better than whey, but it was better than casein. And soy is a plant-based protein. Casein is a solid milk-based protein. So this is what we can see over here. Hold on one moment.